Hi everyone, last questions with writing quadratic equations, just 2 quick word problems. I know that last video was on the longer side, so let's try to get through these ones quickly. Of course, in class I will answer any questions that you have. Number 1 here, I want to find the dimensions of a rectangle that has the greatest area if the perimeter of the rectangle is 36 meters. I'm going to draw myself a rectangle first. And think about what I know about this rectangle. We still really only want to have one letter. I'll call my width W in this rectangle. If my whole perimeter is 36, then I can take away those 2 W's and divide what I have left over evenly by 2. So if I have 36, I take away my 2 W's and I divide in half. That means my length here is going to be 18 minus W. Now to find area, I'm going to multiply. Area is equal to W times 18 minus W. What the heck though? We don't know the area. That's okay. Area is going to be equal to, well, I'm going to rearrange. I'm going to have negative W squared plus 18W when I distribute. And what I'm asking you here is to find the greatest area. Another word I could say here is the maximum area, which hopefully would clue off that you need to go and think about the vertex. Here's my grid. If I were to graph this, let's see if this will fix it for me. Oh, look at that nice parabola. What I'm trying to find is the maximum area. Remember what you're measuring though. Measuring width on the x-axis and area on the y-axis. So I'm looking not for the x value, I'm looking for the y value. I need to find the x value first though, because I know that my x value is negative b over 2a. So here's my equation. I rewrote it so things were in order. Negative b over 2a is going to give me positive 9. That means that my vertex over here is at 9 comma something, and that something is what I want. When I plug in 9, let's switch colors here, I'm going to have negative 9 squared plus 18 times 9. That's going to give me an answer of 9, but what is that? That is 9 meters squared as my max area. Now, what I want is the dimensions. The dimensions here, my width is going to be 9. My, when I plug that in back over here, I get 9. When I plug that in over here, I get another 9. So what's happening? I have a 9 meter by 9 meter. Shoot, I did something wrong. Sorry, that should not be 9. I get a 9 meter by 9 meter rectangle, well, in this case, square. I did the calculation wrong over here, but if I had not, that number, whatever it is, would be the maximum area. All right, so depending on the questions that I ask you. One more question, and then, we'll do some of these together at some point. This is a very classic quadratics question. A ball is thrown with initial velocity 56 feet per second. There are actually very specific equations for this. And every single equation you see is going to be either negative 16 if we're measuring in feet, because that is actually gravity, or negative 4.9, which is gravity just measured in meters per second instead. All right. Let's draw ourselves a picture to think about what's going on here. When I draw a picture, well, eventually we might get more complicated ones where we throw it off a ledge. But for now, we're going to throw from the ground. I'm going to throw from the ground. It's going to go up. It's going to go down. I don't really care about anything outside of my quadrant 1 because it's not digging into the ground. Here's my equation. My time is on my x-axis, and my height in feet is on the y, and I'm measuring in feet per second, so time is in seconds. What is the height of the ball after 1 second? That's just asking me for the y value when I plug in 1. When I plug in 1, I get 56 minus 16. So my height is 40. Not just 40. It's 40 feet. What is the maximum height of the ball? Well, that is that question I was trying to answer on the last question, and I bungled it up. This one is going to be not my time, but my height up at that vertex. So first thing I need to do is find the vertex. I may rewrite this, negative 16t squared plus 56t. I'm going to find negative b over 2 times a. When I do that, I'm going to get 7/4 as my time. That's when it will reach the maximum height. What is the maximum height? Well, I've got to plug that into my formula. I'm going to have 56 times 7/4, so I'll write 56 over 1, minus 16 times 7/4 squared, which I'll just write as 7/4 times 7/4, because really we shouldn't have calculators. 4 times 4 is 16, so that's actually super nice. When I simplify my 56, let's see, 4 goes into 4 once. Does 4 go into 56? I think so. It goes in 14 times. Now this is much nicer. I'm going to have 14 times 7 minus 7 times 7. What I might do, again, because I don't have a calculator here, is factor out a 7. So 7 times 14 minus 7 is going to give me 7 times 7, which gives me 49. Well, some of those tricks, right, from not having a calculator. What is this? It's the maximum height, so it is being measured in feet. Now, this particular question has a little bit of a cheat for question C. What I know is that this graph has symmetry. And because this graph has symmetry, and I started at 0, 0, I know that 7/4 is my halfway point until I get back to the x-axis here. So what can I do? I can just double 7/4, and that is going to give me 7/2, because my 2 and my 4 cancel. So really I want this in seconds. That's going to be 3.5 seconds until it reaches the ground again. All right, we'll see more of these. We'll see some more complicated ones eventually. For now, some of these are good to try. Again, I'll have the worked out ones when I do eventually post this. Ask questions. Thanks, everyone. Hope these were all clear.